Here's my solution for the fifth video assignment. I'll be doing the question 16-140. So it says that we're given the angular velocity of omega AB, which is 4 rads per second, the angular acceleration at AB, which is 2 rads per second squared. The distance from point A to C on this little schematic over here is 3/4 meter, and the distance from C to D is 1/2 meter. So here is the schematic that I drew over here, just something really simple with the theta as well, and all of the distances and lengths. So we need to figure out what omega CD is and what alpha CED is. So the governing equations that we're going to use, or the assumptions as well, is that the velocity at point A is 0, and so is the acceleration at point A. That's because that's the pivot point. So we're also going to use the equation of VC equals VA plus omega, cross product with RCA plus VCA XYZ. And we're also going to use the big equation of AC equals AA plus dot omega, cross product with RCA plus omega, cross product with the cross product of omega and RCA plus 2 omega, cross product with VCA XYZ plus ACA XYZ, which is a really big equation, but it's going to help us solve at the very end. So we're going to assume that omega is 4 rads per second going in K, and that omega dot is 2 rads per second squared going in K. So RCA is AC, which is 0.75 meters going in X, and VCA XYZ has to be going in the X direction as well as the ACA direction. So first we must find what VC is. So we're just going to use the regular equation of VC equals omega D cross product with RCD. And after getting all the vector components, we see that VC equals negative 0.25 omega CD going in I plus 0.433 omega CD going in J. So using this, we can sub it in to find what AC is. So AC, we're going to use the equation of AC equals to alpha CD cross product with RCD minus omega squared at CD multiplied with RCD. So we know what this is going to be, we don't know what this is going to be yet, but we can add all the numbers in and simplify it to get something that's going to help us later. So AC becomes 0.433 omega squared CD minus 0.25 alpha CD, all going in the I direction. And then in the J direction, it will be 0.433. It will be the same thing, basically, but with these signs reversed going in the J direction. So finally, we can sub in VC and AC into our star governing equation to solve for omega CD. So we're going to sub it into this equation right here. So that means VC equals VA, which gets crossed out because it's 0, plus omega cross product with RCA plus VCA XYZ. So we can't exactly solve it yet. That's why we're going to have to simplify it as much as we can and then solve it in X and Y components. So before the X and Y components start, this is how it will look like. And then in X, when we solve it, it will be 0.5 sine 30 omega CD equals VCA XYZ. And then in Y, we can simplify and say that it equals to 0.5 cos 30 omega CD, which equals to 3. And then simplifying that, just dividing 3 by 0.5 cos 30, we see that omega CD is 6.93 rads per second. And this is one of the requirements that we need to find. So now we know that what omega CD is, we can sub it into the big equation that we had before, one of the star equations, to find VCA XYZ. So we're going to use the X component here, and VCA XYZ equals to negative 0.5 sine 30 omega CD. Simplifying all of that, we get negative 1.75 meters per second, and that's going in the left direction. Since my coordinate system is up is plus J, and right is plus I. So now that we know almost everything, we could sub it into our big star equation to find alpha CD. So we say that AC equals to AA, which is crossed out, plus dot omega cross product with RCA plus omega, which is cross product with the cross product of omega cross product with RCA plus 2 omega cross with VCA XYZ, which we now know, and ACA XYZ, excuse me, and we can simplify that now to figure all of this big mess out. But we can simplify it a little bit more. This is just us plugging in the equations. We can see that it's 0.433 omega CD squared. So I just plugged in 6.93 for omega CD. And I did the same thing for everything else, plugged in all the values that we know before, all of our assumptions. And then we could simplify it to something a little better. So I grouped it up like this. I did 20.795 minus 0.5 sine 30 alpha CD plus 12 is all going in the I direction. Is all just one big I component. I grouped everything together. And 0.5 cos 30 alpha CD plus 12.36 plus 12 is all going in the J component. And I isolated for ACAXYZ, which is going in the I direction. This is going to make solving for components much easier. So I could just cross out one large equation. So for x, I cross out the entirety of the j component, and I could see that I can't really solve yet. But in the y component, when I cross out the entire when I cross out the I component for solving for y, I can actually solve for alpha CD, which is just a little bit of math, and that gets us 56.26 rads per second squared. So now we know what alpha CD is, we can solve for ACAXYZ as well. So I just get this number, I plug it back into the x direction, and simplify it, and I get 46.86 meters per second squared. And that's all.